So I'm back with another video, and in this video beta we are going to discuss a brilliant question from JEE Advanced paper 2. So this is a question from JEE Advanced paper 2, and this question is one of the good question that has been asked in the JEE paper recently. So let us discuss this question in detail. So a uniform circular disk of radius 0.2 meter and mass 1 kg is pivoted at its top point C such that it can rotate freely around C, okay, in XY plane. Initially, when the disk is at rest, particle of mass 20 gram, this is the particle of mass 20 gram traveling along negative x direction in the XY plane with speed 100 meter per second hits the circumference of the disk at point P. So this is the point P. After collision, the particle moves along negative y direction at a speed 90 meter per second. So beta, in this question, they are asking that after collision, the disk starts to rotate around the point C. What is the maximum change in the height? Okay. So if we discuss this question, one thing is sure in this question that if this particle, let us focus on this picture, if this particle mass m is striking this disk and which is hinged about this point C, we can easily say that there is no, if we consider both as a system, there is no external force or torque acting on the system. So we can easily say that angular momentum of the system will remain conserved. Okay. So angular momentum of the system will remain conserved. Now, if we say initially this is at rest. So it does not have any angular momentum. But if we talk about this mass particle, then it is of course moving with some velocity v. Okay. And if we talk about the angular momentum of the system, now what is the system? What constitutes the system? That is this disk as well as this particle. Okay. So if we talk about the angular momentum of the system beta, about which point? About C. It is convenient to take this conservation about the point C. So if we talk about the angular momentum conservation about the point C, then what is the initial angular momentum of the system? Okay. So let's talk about the distance firstly. This is the axis of rotation and this distance is r. This is also r. So we can say this is r sine 45, so r by root 2, and this is also r by root. Okay, so if we talk about the angular momentum of the particle, then it is m v initial into r perpendicular from the point of rotation. And after that, this particle is going in this direction. So now we have to take this r perpendicular, this one. Initially, we have to take from the axis. This is the first r perpendicular which we have to take. So m v initial into r perpendicular. Now after the impact, the disk will rotate with omega. So I omega plus m v final into r perpendicular. Now this can be written as prime. So now putting the values m v initial, r perpendicular is r plus r by root 2, that is equal to I. The moment of inertia of the disk about this point is mr square by 2, that is about the central axis, isn't it? And about this plus mr square, so we can write directly as 3 by 2 mr square and plus m v final into r perpendicular final. And what is r perpendicular final? That is only r by 2. Now let us back to the question again. Initially, the particle was moving with 100 meter per second. And after the collision, particle moves along negative y with 90 meter per second. Okay. So you are given the mass as 20 gram. So you can put as 20 by 1000. Initial velocity as 100 meter per second. Final velocity as 90 meter per second. You are also given the radius, I guess, radius is around 0.2 meter, and the disk mass is 1 kg. So disk mass is 1 kg, radius is 0.2 meter, isn't it? Now, so we can put the values here, and after putting the value, we will get the omega, and the omega will come out to be as beta 7.13 radian per second after the calculation. Now, this question has said that after the impact, the disk center will move upward to some extent. Okay, so from here we can apply the conservation of energy or conservation of mechanical energy. Let's talk about the disk. If this is the disk, okay, and if its center is somewhat going this way, so this is the height it is gaining. So we can write it is gaining mg r 1 minus cos theta, and from where this energy will come from? From half of I omega square, that is the rotational kinetic energy. Okay, so from here you will get the height raised, which is r1 minus cos theta. This is the height raised by the particle, and this r1 minus cos theta will come out to be as 0.15 meter. Is that okay? So this is the height raised of the particle. Now, the second question that has been asked is the amount of energy loss in collision. Now, what is the energy loss? So we can write the kinetic energy loss as initial kinetic energy minus final kinetic energy. Okay, so you can calculate the initial and final kinetic energy as well, because you have the initial kinetic energy as the movement of the particle and final kinetic energy as the difference of the you can say the kinetic energy of the moving particle as well as the rotational kinetic energy of the disk as the total kinetic energy, final kinetic energy of the system. So by putting the values, you will get the answer as the loss in kinetic energy as around 17.47 joule, if I am not wrong, as calculated. Okay, so this is the concept, one of the brilliant questions that has covered uh, very important topic, that is conservation of angular momentum and the conservation of mechanical energy in rotation. For more such videos, you should subscribe the channel and like the videos. You must share the video with your friends also. Thanks a lot. Have a great day.